Girls, I'm going to be differentiating exponential functions today, but first, just a quick review of what exponential functions are. Here is an example, y equals 2 to the power of x. So let's substitute. Let's start with when x is 0, 2 to the 0 is 1. What's 2 to the power of 1? 2. 2 to the power of 2. So, you know, when x is 1, y is 2. When x is 2, y is 4, etc. What about negative 1? What's 2 to the negative 1 mean? What does negative power mean? 1 over. So that means 2 to the negative 1 means 1 over 2 to the 1, or a half. So that hence down here, when x is, when x is negative 2, it would be a quarter, etc. This is an asymptote down here. That's 2 to the power of x. Now, I'm going to differentiate it. Now, we don't know how to differentiate things with powers. So, if I want to differentiate that, there's no rule. This is what I'm going to do. If my function of x is 2 to the x, then differentiating from first principles, f dashed x is, do you remember the rule? Limit, limit, this is first principles, limit as h approaches 0 of function of x plus h minus function of x over h. Do you remember this? All right, we did this in prelim. It's called differentiating from first principles. And it was when, I hope I did it, it was, that's the rule. So, remember it's the tangent at the particular point. That's what, remember first derivative, when you differentiate, you're finding the gradient of the tangent. When I first introduced gradients to you, we were working out gradients of secants like this, and then we were making it smaller and smaller and ending up with the gradient of the tangent. And one way of doing it is to use this process called differentiating from first principles. And this is the method, and I'm hoping we can go back into the year 11 and find that video and maybe watch that tonight as a review. It is year 11 work, but you may be thrown a differentiate from first principles question in the HSC, maybe worth 2 marks. This is the formula. So f dashed x, the first derivative, is the limit as h approaches 0. Could h ever be 0? Okay, so what it's doing, it's working out the gradient of this secant. But as the secant gets smaller and smaller, you end up with a tangent where you're only touching the curve at one point. Okay? Of function of x plus h minus function of x over h. Now, function of x plus h means, here's my function. What do I replace the x with here to do function of x plus h? That's function of x. What's function of x plus h? Replace the x with an x plus h, and you get 2 to the x plus h. So that's my function of x. If I replace the x with an x plus h, I get 2 to the x plus h minus, what's function of x? No, what's function of x? 2 to the x over h, which is the limit as h approaches 0. See this? You learn that formula with the star. Limit as h approaches 0, function of x plus h minus function of x over h. What that formula does is just work out the gradient of the secant as it gets really, really, really small. And when h becomes 0, but it never can, because this will be undefined if it does, you actually get the gradient of the tangent eventually. Okay, now, how can I break up 2 to the x plus h? 2 to the x times 2 to the h minus 2 to the x over h. So it's the limit. You won't be doing this again. Limit as h approaches 0. Can I factorize out anything? Yeah, I've got 2 terms there. How do I know? Because terms are separated by plus and minus signs, not with times. Times means that's one term. So I've got 2 terms here on the numerator, and 2 to the x is part of both of them. So 2 to the x is a common factor. What can I pull out as a 2 to the h minus 1 over h? So now I'm going to take that 2 to the x out to the front times the limit as h approaches 0. Now normally when you do this, so 2 to the h, that's a big minus 1 over h. Now, I can't substitute 0 into that because it would be undefined. So what you do, I want you to put a really nice small value of h. Can I have someone doing, let's do 0 point, put 7 zeros and a 1. So I want, let's just sub, h is 0.1, 2, 3, 4, 5, 6, 7 zeros and a 1 into that expression. So you've got to go 2 to the 7 zeros, 0.000, 7 of them with a 1 on the end. Then minus 1, make sure it's a big minus 1, not a power. Make sure that minus 1 is not a power. Get an answer and divide it by 0.00007 of those with a 1. Give me an answer.
I've got 0.0006.
No. It should 923. 6. No. So it's that times 0.693 approximately. Whatever. So girls, when I differentiate function of x, when I differentiate 2 to the power of x, my answer is 2 to the power of x times 0.69314, which is just a constant. Okay? Now this is what we're going to do. That answer means nothing. But you do get 2 to the x times a constant. Now, we're doing the same thing with function of x is 3 to the x. So therefore, this is my first example. This is my second example in my investigation. If function of x is 3 to the x, f dashed x will be limit, I'm doing it again, as h approaches 0. So can we do the same process with 3 to the x of function of x plus h minus function of x over h. Now girls, what I'm doing here, I'm deriving the rule we're going to use today. I know a lot of you know the rule and say, why don't you just get on with it, miss, and put the rule up there. The thing is, for harder type questions, it's good to know this background stuff. Alright, it helps you with application type things or to understand. Yeah, just that. This is just a observation at the moment. We're just observing here. Now, you're going to, yeah, we have differentiated, but you can't do it accurately. Alright? So, we are going to get to a value somewhere between, you know how pi is 3.141 whatever? Well, there's another number called e. And e is 2.7 something, and it lies between 2 and 3. So that's why we're looking at 2 to the power of x, and we're looking at 3 to the power of x, and then we're going to look at e to the power of x. And you're going to see something very special about e to the power of x when we do it. Alright? So we're just doing the same thing. So it's the limit as h approaches 0. Now function of x plus h, isn't that just 3 to the x plus h? The reason I want to do it, it's a good review of differentiating from first principles. So it's 3 to the x plus h minus 3 to the x over h.
Do you want us to use the same number?
I want you to still pull out that 3 to the x.
Yeah, but when we sub it.
Yep, a nice small one. So 3 to the x is a common factor. So then, it's 3 to the x times the limit as h approaches 0 of 3 to the h minus 1 over h. Now, you're going to substitute that really small h again, and you should get 1.0 something.
1.0981.
Now, that's close to 1, isn't it? Notice, when we did 2 to the x, we got about 0.7. When we did 3 to the x, we got 1.09. When we do e to the x, you're going to get exactly 1. Exactly 1. And that will be why the rule for differentiating e to the x. Alright, you sub in. So it's the limit as h approaches 0. So you just put the smallest value of h that's close to 0 that you can find, which would be, I would just sub again, h is 7 zeros and then the 1 or whatever. You know what I mean? Or as many as you calculate it fits. 8 zeros and a 1, whatever. 7 zeros and a 1, 8 zeros and a 1. I put 7 because I think your calculators do 8 decimal places. Can't remember.
It'll show up with the same number.
Yep, you should get the same number. So now, we notice, geez, this is almost 1. So now we're going to do e to the x. So you'll need your calculator for this one. Can I get rid of this now? So, who said no? You can look at it. Got it? Hurry up. So can someone now start off with example 3. Function of x is e to the x. So f dashed x is limit. I want to go to the next page. Guys, can I go to the next page? If anyone wants this, come and get it. Send it up the back. If function of x is e to the x, then f dashed x will be the limit as h approaches 0 of function of x plus h minus function of x over h, which is the limit as h approaches 0 of e to the x plus h minus e to the x over h. Keep doing the same thing. Limit as h approaches 0, e to the x times e to the h minus e to the x over h. Pull out e to the x as a common factor. Bring the e to the x out the front. And we better learn how to use e on our calculator. Now e is, and again we're going to substitute, h is 7 zeros after the decimal point with a 1. So we're doing exactly the same process, but we have to find the e on our calculator. And e is on top of the ln button. I'll just pause the video. So e is on top of the ln button. We're going to do e to the point 0, 0, that thing with 7 zeros after the decimal point and a 1 over the h, that small h. Limit as h approaches 0, you can't sub h is 0 in there, you would get undefined. You put the smallest value of 0 that your calculator will let you do, minus 1 over that, and you get 1. So therefore, the derivative of e to the x is just e to the x. No, it's e to the x times 1, which is e to the x. And that's our rule for today. If y is e to the x, then y dashed is also e to the x. Or you can write it as, if y is e to the x, then dy dx is e to the x. Remember, there are 3 ways of writing it. Or you could write it as follows: if function of x is e to the x, then f dashed x is also e to the x. Can you see why? So rather than just telling you, we have derived that result. E lies somewhere between 2 and 3. It's approximately 2.71828, etc., recurring. And it is only when you differentiate y is e to the x that you will get e to the x times 1. When you differentiate y is 2 to the x, as we saw before, you get 2 to the x times 0.693. And when you differentiate y is 3 to the x, you get 3 to the x times 1.09. So this is the only value that when you differentiate this function of e to the power of x, it's an exponential function, that you get the same answer for the derivative. Okay? We'll do some examples now. Before I start on examples, in other words, if I draw y equals e to the x, and I could do y equals e to the x by just substituting values. That's how you could do it. Right? I'm not going to draw it accurately, but e to the 0 is what? E to the 1 would be 2.7 approximately. Of course, this is not to scale, if I was to draw it. E squared is whatever you get. E to the minus 1 is whatever you get. Point something. Girls, you know the function for e to the x? If I draw it, what's the derivative function? The same thing, it's straight on top of it. Do you get what I'm saying? But the derivative function for 2 to the x is slightly different. And the derivative function for, like, if I drew 3 to the x and then drew the derivative for 3 to the x, very slightly different because it's 3 to the x times 1.09. But the derivative for e to the x, if I was to draw e to the x and if I was to draw e to the x, the derivative, they're on top of each other. They're the same function. Got the idea? If I was to sketch it. So e to the x is the function, it's also the derivative function. Alright? You don't need to. That was just an observation. I really need to get moving. Now you'll be asked in questions 1 and 2 of the textbook, look here, to work these out. You just use your calculator. You okay there? Question 2, sketch. Do a table of values, please. Question 2, table of values. Now, question 3, we'll differentiate some of these. Okay, I'll just make some up. We are, but I'm going to make some up because you're going to do all those. Example. These are based on question 3. Differentiate the following. If y equals 8e to the x, what's dy dx or y dash? Yeah, the constant stays and the e to the x stays. Because if you differentiate the e to the x, you get e to the x. If I was differentiating just, say, 8x, what would I get? 8. Yeah, but if I'm differentiating, if I was just differentiating, say, 8x, I would just get 8. Right? So when you differentiate, the constant will stay, then we differentiate e to the x and we just get e to the x. So if you differentiate e to the x, you get e to the x. Alright? If you differentiate 8e to the x, you also get 8e to the x. So that's the first example. If I differentiate negative 5e to the x, what do I get? Negative 5e to the x. Same thing. And that will be your most basic type. Now we've got some others. Let's differentiate e to the x plus x cubed plus 7. What's y dash? So my function is e to the x plus x cubed plus 7. Differentiate it. What do you get? E to the x is the same. Plus 3x squared plus 0. Remember, when you differentiate the constant, you get 0. I'll go plus 0, which is e to the x plus 3x squared. So we're just adding on the extra rule of differentiating e to the x. I want you to differentiate e to the x plus 3 to the power of 5. Now, girls, if that was something in here, to the power of 5, how do we do this type? Don't we bring the 5 to the front? So we get 5 bracket, write down whatever is inside. Now what do I do? To the power of 4. But then I don't ignore what's inside. What do I do with what's inside? Times by the derivative of what's inside, which is just e to the x plus 0, or just e to the x. So you bring the 5 to the front, write this out, drop your power by 1, but then of course you differentiate what's inside. And so I would write it as 5e to the x, bring that e to the x to the front, and then write the rest of it out, e to the x plus 3 to the power of 4. Are you allowed to expand that? No, because it's power of 4, and that's quite a big expansion. We'll be starting binomial theorem on Thursday, so you'll see that you aren't allowed to expand that. You could, but it'll take you about 5 lines, and there's no need to do it. Next one, differentiate the following. Oh, I'm hungry. Now that's all on video. Okay, go. How do you do it? Y equals 3 e to the x minus 4 cubed. What do we do again? Bring the 3 to the front. 3 e to the x minus 4 squared times, don't forget to differentiate what's inside, 3 e to the x. Now, we don't like to keep those two separated. The 3, you can do 3 times 3 e to the x is, 9 e to the x bracket 3 e to the x minus 4 squared, leave it as is. Now, we're going to do some product rule and chain rule, no, product and quotient rules. Keep going. This one, differentiate x cubed e to the x. All right, you need to set up your rule. Which rule is this? Are there two functions in x? Product rule, because we've clearly got two functions in x. U is x cubed, that is the first function with an x in it, and v is e to the x. So what's u dash? And v dash? E to the x. So y dashed is, look, you can do VUV if you want with a plus, but I do uv dash plus vu dash. It doesn't matter. Yeah, who does uv dash plus vu dash? Who does VUV, vu dash plus uv dash? Same. I don't mind. I think we've got more people doing vu dash plus uv dash. You know what you do? You say product rule's the easier one, so it's got the plus, because pluses are always easier. That's how you remember it. So you can keep the VUV, vu dash plus uv dash. Keep it the VUV. This is the easier one. It's got the plus. I think it's on the formula sheet now anyway. So v u dash plus u times v dash. Now, of course, if you can, you have to pull out any common factors and factorize. E to the x is a common factor, and what's left? 3x squared plus... Oh yeah, let's do the x squared as well. So not only is e to the x the common factor, there's an x squared as well. So it's x squared e to the x, and by convention you'd write the x squared first. Sorry. Now what's left? 3 plus x. That's better. Must be fully factorized if you're going to factorize. Yep, that's that one. So that is a product rule. Let's do a quotient rule. So y is e to the x over x squared. Okay. You'll be doing the whole exercise. I'm on question 3 now, and then look, we're 23 minutes. All right, 23 minutes. So, what about this one? U is e to the x. No, u's always on top. Alphabetical order. U comes before v. Top comes before bottom. Everything's in order. V is x squared. U dash. V dash. All right, this is e to the x. That's 2x. So y dash is v u dash minus u v dash over v squared. All right, I'm changing over. One sec. Give me a sec. Got it?
So would v squared be x to the 4?
Y dashed is v squared is x squared squared x to the 4, yep. So what have I got? V times u dash minus u times v dash over x squared squared. So any common factors on the numerator? And another x. So it's x e to the x, girls. We put the x first and then the e to the x. Open bracket, what's left? X minus 2 over x to the 4. We can actually do some cancelling. Where? One of the x's with one of the x's down here. So we've got e to the x, x minus 2 over x cubed. We can cancel out the x from the numerator and the denominator, only because that's being multiplied by the whole bracket. If there was no bracket here, forget it, because it's that times all of this over that, so we've only got multiplication symbols. You can divide numerator and denominator by x.
Wait, so what did you say about if there was no bracket?
If there was no brackets and I had x e to the x minus a 2, you can't. As soon as you see pluses and minuses that are outside of brackets, forget cancelling. Okay, another example, example 8. All right, if the function of x, I'm just doing similar ones to what you've got, is x to the 4 plus 2 to the x minus 3e to the x plus e to the x, find f double dash 1. All right. You know what to do? Wouldn't you just find f? Yep. So let's just start off by finding f dashed x and f double dashed x. Yeah? We still have to do volume problems, maximum, minimum problems with this too. Oh, that's with integrating. All right. F dashed x is
4x cubed plus 2
minus 3e to the x plus,
e.
you know what? What could I have done with this? Haven't I got like terms?
Yeah.
So I've got,
Does it matter?
no, well, we can do it later. Next time, I just made this up, you see. So I've got, what have I got now? 12x squared. The 2 goes.
Minus
3e to the x plus e to the x. Now, I'm going to, they are like terms. Minus 3 lots of e to the x plus 1 lot of e to the x is really just minus 2 lots of e to the x. And I could have done that on the first row, but I made the question up. So, you know, now we do sub in 1. F double dash 1 equals 12 times 1 squared minus 2 times e to the 1. Now, you do not go and put it in your calculator. Leave everything as an exact answer. So the most exact answer is 12 minus 2e. Because e to the 1 is just e. Leave your answer as an exact answer unless otherwise stated. I'm going to write find f double dash 1 in terms of e. That way it tells you to leave it in terms of e.
If it doesn't say in terms of e, do we just...
You would just, you don't need to, unless they say to 1 decimal place, but you would put it in terms of e first and then work it out in case this is what they want. Look, generally in mathematics they want the exact answer and that's the exact answer. Okay, why don't we find, here question 9, let me see. All right, find the gradient of the tangent to the curve y equals e to the x at the point 2. Actually, instead of gradient of tangent, I might ask for the equation of the tangent. Sorry. That way, I do gradient of tangent and equation of tangent, and that's going to be my last question, I think. So if I wanted the gradient of the tangent, you just work out the first derivative and substitute in the value. I'm going one step further and asking for the equation of the tangent to the curve. Now, this is the same as doing it for any normal function. You follow the same steps. How do you find equation of straight line? We're going to use point gradient formula. You need the gradient. How do you find the gradient of the tangent? Differentiate.
Wait, when we differentiate and we sub it to the x.
That'll give you the gradient at 2.
Do you want us to keep it as e?
Yes. Girls, I want you to keep this as exact values. At no point do you put it into your calculator. So let's just, we've got y equals e to the x. Y dashed is e to the x. At x equals 2, y dash is, so girls, first derivative gives you the gradient function. When x is 2, y dashed is e squared. So therefore, the gradient of the tangent at 2e squared is e squared. That's the...
If it was a normal, would it be negative?
Yes, if it's a normal, yeah, we'll flip it. We can do that in a minute. We'll do one of those. So therefore, the equation of the tangent, we're going to use the point gradient formula. Y minus y1 equals mx minus x1. So we've got the gradient and we've got the point. So we go y minus e squared equals e squared bracket x minus 2. So girls, if I ask for the gradient of the tangent to the curve, your answer would be e squared. That's now some of the questions in the textbook. Questions 5, 6, 7 ask for the gradient of the tangent. You would stop there. Once I ask for the equation of the tangent, you use your gradient and a point on the line, or the point where the tangent is. Now expand and collect like terms if we can. Y minus e squared equals x e squared minus 2e squared. See, because you've got like terms. X e squared minus 2e squared, take the e squared, the minus e squared over, and you get plus e squared. Whoops. And then you get y equals x e squared minus e squared. Look, you don't have to pull out e squared as a common factor. You could write it as e squared bracket what?
X minus 1.
If you had to. But that's fine. See, this is in y equals mx plus b form, no problem. Okay? You don't have to do that. Alright? Are we all good? Alright. So girls, you'll notice that I paused accidentally. So, equation of normal to the curve y equals negative e to the x at the point where x is 2. We've just done a quick sketch. That's y equals e to the x. This is the negative of each of those values, negative e to the x. So here's our function, here's the derivative. When first find the gradient of the normal, so don't do your flip now. So when x is 2, the gradient of the tangent is negative e squared, just substituting x is 2. But we want the equation of the normal, so therefore the gradient of the normal is the negative reciprocal of this. So if it's negative, it's now positive. And then it's 1 over whatever you've got. So it's 1 over e squared. It's negative 1 over e squared, which is 1 on e squared. So also, we've got our gradient, but we don't have the point. So when x is 2, what's y? It's negative e squared. So there's my point, there's my gradient. Therefore, the equation of the normal is y minus y1 equals m bracket x minus x1. So it's y minus,
Y plus E.
that's right, y minus negative e squared, I'll just write it like that, is 1 on e squared x minus 2. So I've got y plus e squared. Now,
Can we bring the E
yeah, this e squared, I'd bring it to the other side. Bracket e squared.
equals X minus 2?
So you're multiplying by equals x minus 2. I would expand. See, this one, I would not put in y equals mx plus b form. I'd write this one in general form. All right? So I've got e squared y. Remember, e is just a number, so I'm going to put it in front of the y. Plus,
Why put the X? You usually put the X before the E squared.
yeah.
Why put the Y?
Oh, yeah.
Does it matter if it's E squared Y or Y squared?
Oh, when it's a number, see, no, that was, I put the x in front of e to the x, not in front of e squared. E squared's a number,
Oh, okay.
all right? It's got no x in it. Yeah, because it's 2.7 squared. Doesn't matter, but e is just a number, but e to the x is a function. So if you've got e squared x, I'd write it like that. But if you've got e to the x times x, I'd write it x e to the x. Simpler function first, more complicated one next.
E to the 4.
Yes, e squared times e squared is e to the 4. Equals x minus 2. Now, if I want it in general form, the x must stay positive.
X.
Everything over to the right. So it's x minus e squared y minus 2 minus e to the 4 equals 0. Look, the other thing you could have done, if you wanted, come over here, if you want, y plus e squared is 1 on e squared x minus 2 on e squared. You could have done that, but you could have done this as well. If you just expanded, you could have had that as well. Homework. All of exercise, all of it. Exercise 4.1, all of it. I've done every example except for the stationary points. Do you remember how to do stationary points? First derivative. Yes, do the stationary points. So I'm asking for every question, including the stationary points. There's no inflections. First derivative, put it equal to 0, solve it. Second derivative, and test those x values